Hi guys, this is topic 4.2, excuse me, for AP Chemistry net ionic equations. Hopefully got your attention. The objective is to be able to represent changes in matter with a balanced chemical or net ionic equation for physical changes, for the given information about the identity of the reactants and or products, and for ions in a given chemical reaction. All physical and chemical processes can be represented symbolically by balanced equations. Chemical equations represent chemical changes. So these changes are the result of a rearrangement of atoms into new combinations. Thus, any representation of a chemical change must contain equal numbers of atoms of every element before and after. And this is related to the law of conservation of mass. A balanced equation is a shorthand way to describe the changes that occur in a chemical reaction. They follow the law of conservation of matter, mass. And that states that in any chemical or physical reaction, no matter can be created or destroyed. The number of each atom is the same on both sides. Coefficients are used to change the number of each particle in the reaction. The subscripts are never changed to balance a chemical reaction. Know that already. So on the left side, you have reactants. The arrow means yield. Right side is products. You have the number in the front. The coefficient is the number of molecules. The subscript is the number of atoms that are present. You have your states of matter. Solid is S, L is liquid, G is gas. AQ is aqueous, meaning it's dissolved in water. You have to know your 7 diatomic elements. They are diatomic when they're found in nature, so H2, N2, O2, F2, Cl2, Br2, I2. So if it says hydrogen gas or hydrogen reacts with something, automatically it's an H2 molecule. Chlorine gas, chlorine reacts, it's automatically Cl2. You should know how to balance, hopefully. When you have mastered writing a balanced equation, you can then write something called an overall ionic equation. Overall ionic equations show how ionic compounds dissociate into their ions when they dissolve in water. If you have solutions of an ionic compound, particularly any sodium, potassium, ammonium, and nitrate salts, or the SNAP salts, they should be written as their ions if you are showing an overall ionic equation. So for example, we have a precipitation reaction here, lead-2 nitrate plus NaCl producing sodium nitrate and lead-2 chloride. The overall ionic equation, you break it down into, let me see if I can highlight this. You break it, so like this lead, so knowing your oxidation numbers, like you practice hopefully, you can see that the lead-2 nitrate breaks up into lead-2 plus and 2 nitrate ions. Your NaCl breaks up into 2 Na pluses and 2 Cl1 minuses. Sodium nitrate, the nitrate, it ionizes in solution. However, you'll notice that this one right here is a solid and it doesn't ionize as a solid, so it stays the same. So this is the overall net ionic equation. You have to know if something is aqueous and ionic, it will ionize. If it's a solid, like it forms a precipitate like that, it means it's not going to ionize. So here's an example of a dissolution, ionic and strong acids and bases. So your balanced chemical equation, like if you put a solid into a solution, so NaCl solid, it's put into solution. So it will ionize when it's aqueous, but for now it's on the left side, the reactant side, it's a solid put in, so that does not ionize on that side. A dissolution example with a non-ionic or a weak acid or base, it will not separate. It will just stay the same, stay together. So there are a couple of weak acids and bases that you should be mindful of, and I'll try to point them out to you when we see them. And when we get into later units, you'll see those as well. And that will tell you what's not going to ionize. So once you have your overall ionic equation, you can actually get a net ionic equation. It shows the particles that do change in the reaction. The ones that are, you notice if you look at this, there are some that are canceled out in the overall. Those are called spectator ions because they're present on both sides of the arrow. It doesn't participate in the reaction itself per se, and it stays in the same state of matter from left to right, reactants to products. So here in this example below, we can see that the nitrate ions and then the sodium ions, they're both present on both sides. They cancel out because they're spectators. So the overall net ion equation, all you have left is a 2Pb2 plus, the 2Cl1 minus, and then the lead-2 nitrate that is a solid, lead-2 chloride that is a solid. A solution of ammonium carbonate, NH4 2CO3 reacts with a solution of silver nitrate to form a white silver carbonate precipitate as shown in the image. Well, you can see it's fine. So write out the balanced chemical reaction, write out the overall net ionic equation, identify any spectator ions, and then write out the net ionic equation. Probably put this on the bottom, or maybe we'll see what we need to do. All right, so number one. So we have a solution of ammonium carbonate, so it's aqueous. We need more space down here. It reacts with a solution of silver nitrate to form white silver carbonate. So silver carbonate, and also the other thing has to be present. So whatever in this double displacement, they'll switch places. So you have to know that when you're forming white silver carbonate, you have to know that Ag is 1 plus and CO3 is 2 minus. So your formula you end up getting is Ag2CO3 solid because it tells you it's a precipitate. That's the thing that doesn't dissolve. And then you have the leftover. You have ammonium, NH4 plus, and NO3 1 minus. That's the nitrate, so they come together. When you crisscross, there's no subscript numbers. This is a precipitation reaction, so this one is actually the solution that it's in. That is the balanced chemical reaction. Number two, write out the overall, this is going to take a while, overall ionic equation. Oh wait, do we balance? No, we didn't. So let's balance really quick. So we have two ammoniums on the reactant side, so I got to put a 2 over here. We have two NO3s, 2 nitrates, so I got to put 2 over here, 2 AGs, 2 AGs, and we're balanced. So net ionic equation, it's going to be 2NH4 plus aqueous plus CO3 2 minus aqueous, it sucks, plus 2Ag plus aqueous plus 2NO3 minus aqueous produces. This silver carbonate is solid, so it does not ionize. So you can probably guess what is going to be a spectator or not a spectator. Plus 2NH4 plus aqueous plus 2NO3 minus aqueous. So you can probably guess that you may see a question, which you probably will, see a question where they're going to give you what is a net overall ionic whatever equation, I'm sorry. And if you don't know how to cancel out correctly, then you won't get it right. So make sure you are aware of what's present and what's going to cancel out. Number three, identify any spectator ion. So whatever is present on both sides as an ion. So it would be, let's see, go from, so we have this here, and then we have this here. Present on both sides, both aqueous, so that's going to be a spectator ion. The two nitrates here and here, so that's going to be going away. So your overall, or that's sorry, your net ionic equation will just be how we wrote this out: CO3 2 minus aqueous plus 2Ag plus aqueous produces Ag2CO3 solid. Ooh, that was a lot. Copper 2 nitrate solution reacts with potassium hydroxide to form a blue precipitate of, so that's your precipitate, that means that's your solid, copper 2 hydroxide. Same questions, write out the balanced chemical equation, write the overall ionic equation, identify any spectator ions, and then identify or write out the net ionic equation. Excuse me. So, oops, my bad. So you have copper 2 nitrate. Solution. So this is aqueous. Reacts with potassium hydroxide. So potassium hydroxide, yeah. So then KOH produces copper 2 hydroxide. So copper 2 is 2 plus, hydroxide is OH minus. Then you end up with CuOH2 solid. So you have the leftovers, whatever the leftover is. You have you have potassium, that's a K plus, then NO3, because that is your nitrate. So plus KNO3 aqueous. If it tells you a solution reacts with something and it forms a blue precipitate, you can probably assume it's a precipitation reaction. That means they're both solutions, both aqueous in the reactants, and then your product, one is solid, the other is aqueous. So we got to balance. 2 nitrates over here, 2Ks, so 2Ks over here, 2 OHs, we're good. Write out the the overall ionic equation. I keep on saying that's weird. So copper is 2 plus aqueous plus 2 NO3 minus aqueous plus 2K plus aqueous plus 2 OH minus aqueous produces, so our solid does not ionize, plus 2K plus aqueous, Jesus, and then NO3, 1 minus aqueous. Oh, jeez. Okay, any spectator ions, notice these are the snap ions as well, the snap salts. So we have 2K pluses on both sides, and then the nitrates on both sides, so those cancel out. So this is my spectator ions, K plus, and the 2 K pluses, and then the 2 NO3 minuses. So you write out the net overall ionic equation, sorry. Keep on saying that, I don't know why. So all you have left really is Cu2 plus aqueous plus 2 OH minus aqueous produces copper hydroxide 2 solid. That's how you get the net ionic equation. This is just good balance, clearly. It's just balancing reactions. So let's try these. These are a little hard. So we have SB2S3. Can't read that actually. So 2, 3, 3, 2, and then 3 and 2. So 2SB, so I'm going to put a 2 in the front over here. I have 6 Cl's, so I'm going to put a 6 over here. I have 6 H's, so I'm going to put a 3 here. Then 3 S's. We're good to go. And then the last one, Al plus HCl produces AlCl3 plus H2. So we have, can't really see that when we read this. So you have the 2 H's, I'll put a 2 here for now. But we see that we have 2 Cl's, we have 3 over here, so what's the least common multiple? It's going to be 6. So that means that this needs to be, change this. This should be 6 Cl's. So 6 H's means 3 over here. I need to put a 2 in front of the AlCl3 and then put a 2 over here. That should be reviewed. But anyway. All right, that's it for now. Let me know if any questions. Okay, thanks. Bye.